Hi, this is Martin Brennan, Product Manager of Imagineer Systems, and today we're going to be looking at how to use the 3D camera solver in Mocha to help out with a set extension inside Nuke. Okay, so here we are inside Mocha, and we're going to track a city shot into the background of this scene. And obviously we want it to go behind the hills, and we want it to move correctly with the camera. So in order to do this inside Nuke, I'm going to actually do a 3D camera solve inside Mocha and use the 3D information to apply a 3D card extension to the background. So in order to do a camera solve, we need to track some objects. So this shot has quite a bit of parallax in it, so we're going to need to do at least 2 tracks to get a parallax solve. If we had a locked off shot where there was just movement in the pan, tilt and zoom, we could just track one layer and use the camera solve off that. But because we've got parallax in the scene, we need to track at least 2 layers. And in this case, I'm probably going to track about 3 because we've got nice big pieces of information in the foreground here. We've probably got a little bit over here we can use, and because I'm going to be placing my city card in the background, I'm going to track this hill back here as well, just to give me some extra information. So let's start with the foreground area here, where we've got a nice big piece of information to work with. If I just scrub through the timeline quickly, we can see that road is appearing at the bottom of our footage and then scrolling under the car. So in this case, I want to use an unlinked track because otherwise my spline is going to move under the truck and then get obscured. So let's set that up now. We'll come up to the X-spline tool and we'll draw a nice big rectangle on the road here. So right across the road, right up to the edge and off the screen, like so. And you can see I've just grabbed the fringes of this road to make sure I grab as much detail as possible. Because even though we've got a little bit of texture information going on in this shape here, the fringes really help to define that plane edge. The next thing I'm going to do is turn on my surface and just align the perspective of that surface to the perspective of the road. The reason we want to do this is twofold. We want to be able to see how our 2D planar track is going when we do the unlinked track, but we also want to be able to set up our nulls later to sit on that road correctly. So I'm just setting up a nice square that moves off into perspective so we can see how our track is going. So I'll turn on the grid too just to see how that's looking in horizon. We can probably go up a little bit further. If I extend that out, we can see how that's projecting, and that's not too bad, so I'm going to leave that there, maybe push it up a little bit further. Like so. And now we can begin tracking. So let's look at our parameters. We've got a minimum percentage of pixels set to 30, and this is pretty low, so I'm going to set it up to 90. When in doubt, set it to about 90. It's going to be the nice balance between efficiency and accuracy. And I'm also going to set it to perspective, because obviously we're moving into perspective. Now, the last thing that we want to do is what we call the unlinked track. If I started to track this normally, the spline area, if I turn on my mat, this mat here would keep on moving with our track off into the distance, and then when it hit the truck, we'd run into some issues. So instead, what we want to do is come over to Link to Track, where we've got Layer 1, and I'm going to call Layer 1 Road, so we know what we're dealing with, and we can see Link to Track is now called Road. Instead of the road, we're going to set that to None. This means now that the spline area will not move as we're tracking, and what will happen is the road information will pass under the spline, a bit like a scanner, and it will keep on tracking the information that's passing underneath that surface. So let's start tracking that now, and you can see that happening in effect. So we come over to the track button, and we just hit track forwards. And now as we turn, and I'll turn on the mat again so we can see that happening, you can see that my surface and grid are moving with the tracking data and staying locked onto the original area that we drew, but our spline is staying in the same spot where we drew it. But we can see that that tracking information is moving correctly because it's getting new information on every frame that's passing underneath that shape. This is very, very useful when you've got to deal with obstructions like this truck, or you're dealing with a very close-in shot where you don't want to keep moving and animating your spline to keep locked onto the track. So we can see how that spline is staying locked down, and our information is passing under the truck without any problems. Okay, so I just stopped the recording to finish off that track, and you can see how that now is flowing across quite nicely. Now, before we continue, what we would like to do is actually relink the spline with the tracking data. So I'm going to just move it right to the end so you can see how that works. And you can see now that the spline is still separate from our tracking data. And if we come back to link to track and reselect road, the spline jumps back to where it should belong. Now you can see now that this spline is underneath the truck, but because we've already tracked the data, it's no longer going to be affected. So we can see now that spline is locked onto the tracking information without any problem. Okay, so we've got our first piece of tracking information done. So now I'm going to go ahead and track this little bush area over here. Now this is one of the areas which is quite interesting because the trees here aren't really planar, but this is one of those situations where we can trick the planar tracker into just thinking the data is straight planes. So I'm just going to draw another spline here, just onto this tree area. And again I'm going to move my surface into perspective to about where those trees are lined up. I'm not going to be too accurate here, we're just going to line that up about there. And we've got about 90 for this one, which is fine, and I'm going to set perspective. Now, I've accidentally started to draw my spline away from one of the endpoints, so I just need to track backwards and forwards. So I'm going to call this layer trees, and I'm going to turn off the cog for the road because we've already tracked it. Very important to do that because otherwise you'll start tracking it again. And I'm going to go back to my trees, and I'm going to track backwards first. So that's tracking along quite nicely. And then we'll start tracking forwards. So we can see here that even though these trees aren't really pieces of planar data, the tracker still thinks they're planar because we've just said go ahead and track it. So you can kind of fool the planar tracker into thinking something is planar just by trying it out. If sometimes it won't work, sometimes it will, but in this case, because we don't have much parallax going on in the texture of the trees here, we're actually getting a really easy track down. So finally what we want to do is draw a shape in the background to track the hills here. So for the back hill we want to quickly scrub and check, and we can see a little bit of subtle parallax happening between this hill and this hill, so I'm going to draw quite a small shape here. I'm going to come around here and just track this area here. I'm going to avoid this power line here just to make sure that it doesn't throw off our track. And again we're going to align our surface to be approximately where that hill is lying. So I'm just going to line that up about there. Just because this hill is sort of facing up this way, we might want to turn it just a little bit more just to fit that slope a little bit better. Like so. And we can begin tracking that one too. So I'm going to set that one to perspective. And again, I'm going to turn off my trees, and we'll call this one back hill. And start tracking forwards. Okay, so I've stopped the recording again, so you didn't have to watch a boring tracking process. And we can now see we've got 3 separate layers ready to use for our camera solve. Now the first thing I'm going to do is turn on my surfaces again and just make sure that my surfaces are small enough. Now you can see here my surface at the moment, it's kind of peeking outside the shape, and we want to, when we're doing a camera solve, make sure it's inside our shape and actually reasonably small. We want to keep surfaces small because the camera solver needs to work out the projection of these nulls, and the smaller the surface, the more accurate the nulls are going to be. So if we look at this one's actually not too bad, and over here we can probably keep this one about this size. So now that we're happy with the position of our surfaces inside the shapes, I'm going to now select all the layers and move across to the camera solver. So I'm going to select the back hill, hold down Shift and select the road to select everything, and I'm going to come across to the camera solver. Now, once inside the camera solver, we can see it's set to auto. Now, we could go ahead and use auto to get the best guess possible, but in this case, because we've got such large parallax going on, it's actually fairly obvious which one we want to use, which is, in this case, large parallax. Now, I don't know what my focal length is, so I'm actually going to hedge my bets and select all of them. I know the camera isn't zooming, however, so I'm going to leave that one off. So once we're happy with our settings, I'm just going to click Solve. So it'll take a little while. You can see it's churning up here in the corner. With a scene this size, though, it'll solve pretty quickly. So we can see here we've got a solve quality now of 98%. 98% is obviously a very good solve, and you can probably get good solve quality right down to about 85%. If you start to get below that, you might want to try tracking something differently or adjusting your surface points a little. So, once we have our camera data solved, we can now export out to Nuke. I'm going to keep my layers selected and click Export Camera Data. Now, under the Export Camera Data dialog, you'll see a format called FBX 6.1 3D Data. You don't want to export this one out to Nuke specifically because Nuke supports a different axis to this version. So you just click the drop down, and we come down to the same FBX data except for Nuke 6.3 v7. The reason it's 6.3 v7 is because this version and above supports FBX correctly. I'll be using Nuke 7 in this instance, but it's good to know that if you've got 6.3 v6 or below, you're not going to be able to get accurate data with this FBX format. So I'm going to save that out, and we'll just name it, and press return. So, now that we've saved out our file, we can go across to Nuke and begin the 3D setup.